Do you know what gradient-boosted trees are in machine learning?
Yeah, I think I have like 3 of those in my backyard.
Not physical trees, you Neanderthal, let me show you. Gradient boosting is kind of like gradient descent. If you recall, gradient descent used the negative gradient of the loss to update the parameters.
Right, I remember that. Update the parameters to decrease the training loss. That's easy.
Now here's the twist. Gradient boosting tries to apply this same principle to decision trees.
Wait, what? You can't do that. How would you even do chain rule on a decision tree?
You don't need to, that's the point. Gradient boosting isn't about modifying decision trees.
So what's it about then?
It's about adding extra trees. This model is an ensemble of decision trees, and its prediction is simply the sum of its trees' predictions. Now the goal of gradient boosting is to add one more tree to this model that will decrease its loss.
Okay, but how do you actually do that? How do you find a tree to add that will make the model more accurate?
Good question. This is the important part. We use the negative loss gradient with respect to the model's predictions. That tells us how to change the model's predictions to decrease loss. If we train a decision tree on this change, then adding the tree's prediction with the model's prediction gives new predictions with lower training loss.
Oh, that's clever. The new decision tree is basically correcting the model's prediction error by nudging the model's predictions towards lower loss.
Precisely. And since the direction towards lower loss is the negative loss gradient, we fit the new decision tree on exactly that. Now let's make this concrete with an example. Simple dataset with one input feature, one output, squared error loss. Our initial model is a single decision tree which has a single leaf which contains all the points and outputs their average y value depicted by that flat red line.
That's a terrible prediction.
Now for the actual training run. On the left we have our model which is being trained over time. In the top right we have the negative gradient of the loss, visualized for each data point. The negative gradient of squared error is just the residual, which makes it easy to visualize. In the bottom right we have the new tree that gets fit on the negative gradient of the loss. This is the tree we're adding to our model at each step.
Whoa, the prediction curve keeps getting better. It's actually fitting the data now.
Each tree adds another correction shaped to lower the loss. In the end, we form a more complex model that actually fits the data just by adding a bunch of simple trees.
So in summary, gradient boosting is like gradient descent, but for predictions instead of parameters.
Pretty much. Follow for more.